So this question is solved, right? This is visible. Is my screen visible to all of you? Okay. So we have solved till this question, right? Now this is we want to find what is given here is that probability of E intersection F is 1 upon 6 and probability of E complement intersection F complement is 1 upon 3 and probability of E minus probability of F is greater than 0 and we want to find probability of F complement. So what is given here is that probability of E intersection F is 1 by 6. Okay, and E complement intersection F complement we can write by probability of E union F whole complement. So it will be 1 upon 3. So from here we can find probability of E union F, which will be 1 minus 1 upon 3 and it will be 2 upon 3, right? So what we know is that probability of E union F is equal to 1 minus probability of sorry, probability of E union F is equal to probability of E plus probability of F minus probability of E intersection F. Okay, this is F. So it is given here. It is 2 by 3. It will, and this is probability of E plus probability of F. This is minus probability of E intersection F. It will be 1.6. So what we have here is that probability of E plus probability of F is equal to 2 by 3 minus 1 upon 6. Uh, so we will have 6, 4, 1. Is it 5 by 6? Yeah, I think. And the condition we have given here is that probability of E minus probability of F is greater than 0. So the first condition we have is probability of E plus probability of F is 5 by 6. Probability of E minus probability of F is greater than 0. So what we can do is that we can take minus here. So it will be probability of E plus probability of F will be less than 0. Okay, now we have this equation and this equation. What we will get from here is that if we add these two equations, we will have is that probability of F is less than 5 by 12, right? 5 as 2 probability of F will be less than 5 by 6, so it will be 5 by 12. Now we want to find what is the probability of F complement. So 1 minus probability of F will be greater than, if we take minus sign, it will be 1 minus 5 upon 12. That means probability of F complement will be 7, greater than 7 upon 12. Now we have only if 1 by 2 is not like less than 7 upon 12, 1 by 3, 1 by 6 on. So answer will be 2 upon 3. So sometimes we just solve the question by with the help of like examples by the putting whether it is which option is satisfying this condition. Okay. Anybody has any doubt? Okay, so I'm considering it as a no, right? Okay. So now we have question. Yes. Yes, you are audible. Yes, this is the question. This one. Yes. Okay. Okay. Yes. You don't need to write it. Well, I will upload it. So if you want to write, you can write. It's up to you. If you have any doubts, you can just ask. Otherwise, you can see all these things. I will give. Yes. Okay, so see, firstly, that's what I've said. That firstly, you need to understand when we say that this probability of a sample space is one, when we say that probability of A must be greater than zero, what we just don't think too much that these are the important properties, right? But when we solve it, like when you solve it, it will come, and then you will use it. Then you will understand it when you solve it, right? This is like maths is all depends on the practice. The more you practice, the more you understand how to tackle the problem. When you have the problem, you will take sometimes 1 or 2 days, it may happen. But like to approach is basically is to apply all the firstly whatsoever definitions you have in your hand. Okay, so sometimes like I told you na, for like that type of question A intersection B, you firstly do is that you draw the Venn diagram. Even here also, if you don't understand what is this, then you try to just make the Venn diagram, and then you use De Morgan's law and all whatsoever. So I think with practice you will know, but all you need to do is that always try to remember what are the small things or formulae you can use here. That's it. I think. Okay. So now this we have this question: a box contains 1,000 light bulbs, and the probability that there is at least one defective. So when we have at least one defective, what we do is that we take the probability that at least one defective. So it will be one minus probability that no defective. Because you cannot solve it like probability of one defective, two defective, three defective out of 1,000 plus. It will be very tough to find that probability. So we will take this simple approach, and we take probability of at least one defective by one minus probability of no defective. Now the second one we have will be probability of so it is given here as point 0.1, right? And the probability that at least two defective is will be 1 minus probability of no defective minus probability of uh, one defective, and this is given here as 0.05. And then we want to find the probability that at most one defective. So at most one defective means probability that no defective plus probability that one defective, right? So it will be probability of no defective will be you from here you can find that probability of no defective plus probability of one defective will be 1 minus 0.05. So we can directly write it here, and it will be 0.95. So if you have any doubt, you can ask. So now this, yes, yeah, yeah, take your time. So this is the question, like similar to the question one person has asked, that what is, if we take randomly one letter from this, like there it is given probability and statistics. Here it is given as assistant and statistics. So what we want to find is, we want to find the probability that they are the same letters. Okay. So now, firstly, just- okay. So firstly, we will find what are the common letters these two words have. Okay. So A, S, I, and T. Right. C is not in assistant. So these are the common letters we have. So what we do is that we firstly take the probability. Now, we want to find that probability that they are same letter. So means we have chosen A from assistant and A from statistics also at one time when we are choosing the letters. So what it will be? It will be the probability of choosing the A from first word and probability of choosing A from second word, and these two are independent, so we will just multiply it. Okay. So now for A, from the first word it will be, we have 2A, so it will be 2, and in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 letters. Okay. And from the second word it will be, uh, it has only one A, so it will be 1 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay. So probability of this, uh, choosing a letter from both the words, it will be 2 by 9 into 1 by 10. Okay, so it will be 2 by 90. Similarly, can you tell me for S, I, and T also? Is anybody solving it? 6 by 90. Okay, so from first word, what is it? It is, I think, 3 by 9. It's 2 by 9, or okay, 3 by 9, and from the second one it is 3 by 10. Yeah, so it will be 9 by 90, right? So probability of S we have is 9 by 90, and then for I, will be okay. So here is 1, and here also. Here is 2, right? It, okay. So it will be 2 by 90 I, and for T is probability of 6 by 90. Okay. So now, the probability of getting the same letter will be 2 by 90 plus 9 by 90 plus 2 by 90 plus 6 by 90. So its summation will be 9, 6, 15, and then 19 by 90. Right. So this will be the answer. Any doubts? Okay. So next we have question here is that suppose this omega is the sample space of the experiment where a three-phase die is thrown with a prime number among the numbers 1 to 6 as faces. Consider a1 as this, a2 as this, a3 and a4 are this, and then we want to find which of the following forms a sigma field. So do you know what is sigma field? Yeah, what is it? But okay, but here we have finite points, so how will it satisfy the condition? Okay, so sigma field is basically we have the empty set and the total space set. Like if we are taking this sample space as phi, and then so that sigma field, what it means is that a this one and this empty set must belong to that sigma field, right? First condition is this. And if a is any set which belongs to this, which is subset of, basically a is any subset of this, right? And a belongs to sigma, then a complement should also belongs to this sigma, right? And if we have a1, a2 up to so much belongs to this sigma field, then its union ai will belong to sigma. And for the for the intersection it should be finite number. Here it can be infinite also. So do you, yeah, actually a field is a different thing. Every like ring field, these things have different properties. Sigma field is, as far as I can understand, it is a specific type of field which will satisfy some definition or some properties uh, on the basis of set. Okay, so field is a different thing, but it field can also be, I think, infinite. I just need to check. I don't remember exactly, but it's not that sigma field need to be infinite or something. But what is uh, given here is that infinite number of union we can take, and if each of the set is inside of that field, then its union will also be in that also. So it will be sigma field. So now if we check, yeah, yeah, you can ask. Boris, I don't know. I don't know this. I may read it and then I may tell you in the next class, but right now I don't know. Okay. So now what we have is that A1 is that uh, this set total sample space and this phi. So this will be whether it will be sigma field or not. Okay. So now we can see that empty set belongs to this. So first and second condition are satisfied. Now third condition is that if we have any two sets and sorry any number of sets, then its intersection. So its intersection will be empty set that is already in A1. And what is its union? Its union is this omega, yeah, whatsoever you say, it's already in this set. So A1 will be the sigma field. Okay, so A1 will be sigma field. Now we will check for A2. So what is given here is that A2, firstly, we have this 5, 2, 3, 1, 5, 1, 2, 3, 5. Now this is the sample space. Okay, sample space of the experiment where three phase die is thrown with the prime number amongst 1 to 6 as the phases. Now if you take this complement also, and you can actually directly take it because here we have not given like phi is uh, 2, 3 and 5. So 1 2 1 2 are sorry, 1 is not there in this sorry in this 5 in this omega or whatsoever you call in this omega, phi is not there. Sorry, 1 will not be there, is not a prime number. So 1 is not, does not in this. So A2 we can directly discard as A2 is not a sigma. Okay. Similarly, for the A3 also we can discard it. Now for A4 we will have omega 5 and then 2 comma 5 and 3. So if we take any two like 5 and 2 5, then its union is present, its intersection is present. So and now if we take complement also, so if 2 and 5, yeah, there is one more condition. If A is present in, I have already given that if A is present in the sigma, then A complement must present in the sigma. So 2 5, what is the complement of 2 5? If we have the set 2 5, what will be its complement? 3. Okay. So its complement is also present, its union is also present, right? Its intersection is empty set, this is present, its union is 2 3 5, which is omega, this is also present. So whatsoever condition we need to satisfy, a sigma field need to satisfy, it satisfies all the condition. So A4 will also be a sigma field. So answer will be A1 and A2. Okay, is it okay? Okay, so these are the question I have prepared for you, but I think I still have a lot of time, so we can discuss whatsoever you have doubts regarding the assignments or anything else. Yes. Okay. Yeah, so that's why I'm here. Na? You can ask me if you uh, like I may not know everything. That is true, but I may like write it down and then I will try to understand and then I will try to think about it and tell you in the next class. That's why you are having the live sessions, right? Okay. Yeah, I can explain what's you can like present your screen, you can tell me whatsoever I need to explain and then I will explain it because I don't have any control on the instructor, sir, right? So those videos are already like recorded, so we cannot do anything in that, but you can ask me, I will try my best to solve your doubts. uh, okay, so can you just share your screen? Okay, Neeraja or Neeraj. Okay, you have written that it will be great if I will take the highlights. Actually, uh, I I will try, but it will be tough for me to just go through all the videos and do the highlights. But I will try. Okay, to take the things I will feel that you will not be able to understand because I myself had did that course I think 2 3 years ago when I needed this. Uh, I needed to understand this probability and statistics. So, okay, okay, I will try. I will try to write the key things so that uh, you will understand it in a better way. Okay, so uh, okay, so what is given here is that if you have any set, we you want to find its infimum or supremum. Do you know how to find this? Do you know, okay, simple meaning of what is infimum or supremum? Yeah, and the supremum is the least. Yeah, so what okay, so what he's trying to do is that if you have just like we have like say a 10 number of sets or infinite number of sets, like I'm telling you it is 1 minus 1 upon n, 1 minus 2 upon n, 1 minus 3 upon n, then these are different sets, like you can take it as e1, e2, e3 and en, right? So 1 minus 1 upon n, 1 minus 2 upon n, 1 minus 3 upon n. So whenever you take the infimum, it will be like if you have n is as a natural number. So if you try to find its limit, so it will be 1 minus 1 upon n when n tends to infinity. So limit means when you take n tends to infinity. So it will be 1, right? Infimum. And supremum, so basically what we are trying to do is that we have several number of sets and then we will take supremum over this. So we will find the supremum over these sets and then we try to find the limit. But these are just, you need to understand what is the difference between theory and applications. So if you are just doing this course for the application part, then these things are not needed at all. But if you want to understand the theory behind it, then you need to understand all these things. So actually I did this before, but let me see. Questions. This is for the first week, right? Not written. Yeah, can you just play the video so I will just understand it, some of it? Yeah, you can stop it here. Okay. Okay, so this chi function is given here is the characteristic function, maybe you know. So characteristic function means that what is the characteristic function, do you know? Uh, Yeah, I think you can take indicator function or characteristic function whatsoever you want. Okay, so no, no, that one is different. But we take it as whether if A belongs to this set, then its value is one, and if A does not belongs to this, then its value is zero. So this is, yeah, okay. So what he's saying is that if you have any element, he's trying to just equate the things. What is the characteristic function of is x e star x, and it will be equal to limit of infimum x is x en, and it will also be equal to limit of supremum. So I think he's just trying to do is that if we have any x in this e star, then what is e star here? Okay, so if x belongs to e star, uh, then x will belongs to en for all but infinitely many values of n. Okay, let me just write it. X belongs to e star, then it means x will belong to en Yeah. No, you are not only one who is facing difficulties. We all face difficulties in understanding the lectures. It's fine. Okay, so I think when X belongs to E star, that means the set of infimum, if you say, uh, X belongs to En. That means X belongs to all the sets we are taking E1, E2 up to En. Uh, and this is for all, means this is for finite number of values, not for all, not for infinite. Okay, so En will be finite. And if X belongs to this E star, if X belongs to this En, so its indicator function will be 1, right, for all these values. Like if X belongs to E1, then X E1 X sorry chi E1 X will be 1, right? No. Okay, 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 okay. So okay, so here you can see that X belongs to En. What it means is that, like, and this is for all but finitely many values of n, which means we for finite values of n, this X belongs to En. Now, if X belongs to En, so if X belongs to one set, its indicator function will be 1 for that set, right? And if X does not belongs to this En, then its indicator function will be 0. So indicator function here is En X is 1 for all but finitely values of n. So if all the values, like for E1, E2, En, every set we have chi or whatsoever you say, indicator function is when a 1, then its infimum also will be 1, right? And when it does not belongs to X does not belongs to E star, what will happen is that X does not belongs to En. And when us value does not belongs to En, what will be its indicator function? It will be 0. Okay, so it will be 0. So what we have again is that we have indicator function of En for X. So this X does not belongs to En, then indicator function for all the En, like for the En X will be 0. Now it will be 0, then we will take the infimum, then infimum will also be 0. So this is only written here, what I have understood. Like if you have a set of all the ones, what will be it infimum? It will be 1, right? If you have a set with all the zeros, then you have, then its supremum or its limit whatsoever you take, it will be 1, right? But it will change in the case, like I have told you, like 1 minus 1 upon n, if you say, then its infimum will be uh, 0 and its supremum will be 1. So it depends, but now here if you have one set and a set contains only one, like chi of en x is equal to 1 for all the n, right? For all the n, for all the finitely many n, then its infimum will also be n. Have you understood that? uh, okay. And you can try it again. Okay, you can just try step by step. Firstly, what he has taken here is that he has taken one element from E star. Okay, so one element when he is taken from E star, he said that this element will belong to En for all but finitely many. Means this X will belongs to this finitely many n's. Okay, so now if any element belong to set, then its indicator function will be 1, and if it does not belongs to n, then its indicator function will be 0. So now it belongs to en, so its indicator function will be 1. Now say for e1 x, indicator function e1x will be 1, indicator function e2x will be 1, indicator function of e1001 will be 1. So for all these thing, indicator function is 1. Okay, so when all the values are 1, when you take infimum of it the answer will be 1. This is obvious, right? And similarly for the second case, if you try to take if x does not, because there can be only two possibilities, if either if x belongs to E star or x does not belongs to E star. So if we will prove something for both the time, like when x belongs to E star, when x does not belongs to E star. So when x does not belongs to E star, what is it means that x does not belongs to En, right? And when x does not belongs to En, its indicator function will be 0. So for all ei, its indicator function will be 0. So ultimately when you take the infimum, it will also be 0. Okay, okay. So you can move to next. Yeah, and if you have any other doubt, you can also ask. I, questions whatsoever I have shared, I will upload it very soon. Means most probably, like I will just upload it. Actually, the my laptop got hang, and that's why its video is not complete. So the first part is not recorded, so it will not be uploaded correctly. But the slides I will upload it just after the class. Okay. Okay, so you can ask me doubts because I need to like uh, take the 2 hour class, so it should be end like after 8 or maybe at 8. So if you have any other doubt or any other question, then I can. So, okay, so if you don't have any other doubt, then we can just go through some assignments I have already. Okay, so let's just see this question. So what is given here is that in a tuition batch of two students, what is given here is that the probability that X will pass the exam is 1 by 4 and Y is 2 by 3. Then we want to find the probability that neither X and Y will pass the exam and assume that outcomes of exams for X and Y are independent of each other. So what it means is that out is it not visible? Yeah. Now it is visible. Now, yeah, okay. So we have a question is that we have a tuition a batch and it just have two students. So we want to find the probability. We have given some probabilities and we want to find. So here outcomes of X and Y are independent, right? Independent means whether he or she will pass the exam does not depend whether the other one is passing the exam or not. So uh, how can we solve this problem? Because it's quite easy, so I just want to know this from you. That we want to find that need. We want to find whether like neither x or and y pass the exam. Okay, so x y pass. So can somebody tell me what approach we can use here? How you have solved this question? Probability of x intersection y will be y. Okay. So it will be 1 upon 4, 2 upon 3. It will be 1 upon 6. Right? Okay. And and the, no, we want to find neither of x and y will pass the exam. Not x, both the x and y are not pass the exam. Okay. So now how we will solve it? Uh, we will firstly try to find what is the probability of x union y. Right? So what it will be? It will be 1 upon 4 plus 2 upon 3 minus 1 upon 6. So it will be 12, 3 plus 6 minus 2. So 3, 4, 8. Right? So it will be 8, 11. What is its answer? I'm doing something wrong. 12. So it will be 3 plus 3, 4, 8 minus. So it will be 9 upon 2. Yes. Hmm. Just a minute. It will be 26. Complement intersection by complement. The probability of one minus x. Can somebody calculate this 1 upon 4 plus 2 upon 3 minus 1 upon 6? Is it 9 by 12? Assume that the outcomes of exam for each x and y are independent of each other. The exam probability that neither x nor y. Just yeah, somebody was telling something. I think. Yeah. I'm sorry. I think we don't need to solve all these things. We can do it directly. I'm so sorry. Okay. So, okay. So give me some questions so that I will solve it, or either you will solve some questions. Don't you have any doubts in assignment? There will be only single lecture per week. Single lecture per week for like this problem session. Asu, Ashutosh. Ashutosh. Yeah, there will be single lecture on Tuesday. On Tuesday, 6 to 8, and then also you are not asking. So I think this is more than enough. Okay, so up to what like you have studied in week two? Is it like random variable is started, or continuous random variable is started or not? There will I will give the uh, I will give the link, and I think they have like this is the folder I have where I upload it, and most probably you will get this folder. I don't know. Okay, so have you already solved that whether a function is CDF or not? So CDF PDF is already started or not yet? Like I think I saw the question in assignment 2. There was question whether a function is a CDF or PDF or not. Is it started? Just tell me, because I have this question in inverse x axis minus infinity to infinity. Okay, like if we have this question, then what we can say that whether f is a CDF or not. So have you solved questions like this already? Have you solved this question? Okay. Have you understood this? So, uh, what we need to do is that this fx, since it is like CDF, or even if we have a small fx, then it should be greater than 0, right? Fx, what is it? It's just, it should be greater than 0, right? So what we want to do is that when x, we just the way he has solved is that when x is minus infinity, when x approaches to minus infinity, then what will be fx? It will be 1 upon pi tan inverse of minus infinity, and minus infinity is, tan inverse of minus infinity is what? What is its value? So what we do is that when function comes, where we can take negative outside. It happens generally. So tan inverse of minus infinity will be minus 90 degree. Like at tan 90 it is infinity. At tan sorry, at tan 90 it's infinity. So minus of tan 90 will be minus infinity. So its answer will be minus pi by 2, and it will be minus half. So minus half can, fx can never be minus half. It can never be negative. So it is not safety. Now, what is the other condition is that it should be a right hand continuous. Right hand continuous means if you have any function, let's say fx, which is 0, say x minus 1, 1 minus x and 1. So this 0, half, and this is x greater than half. Okay. So if you take this question, what will be, will it be CDF or not? So I have already given you hint, right? That if the CDF needs to be greater than 0, and it's at infinity it should be 1, and mm, uh, was this third point is that it this effect should be right hand continuous. So if you see at this point it is 0, and if you see at this point then at 0 it is 1, right? So it is not right hand continuous. Is it okay? Yeah, right. So okay. Now, if we take similar question as 0, x and 1, and we have same values like 0 and 0. So here this is right hand continuous for 0, like when x is equal to 0, it is 0, and here also it is 0. So it is right hand continuous at this point, but when it comes to half, it is half, but x greater than half, it is 1. So what you have is that you have 0, and then you have half, but then at this point it is this. So at this point it is not right hand continuous. So if it is not right hand continuous, then it will not be a CTF again. Means if you think generally, you will think that this is a CTF, but it is not. Okay. Okay, so I will upload these slides after this class, and I don't know, like maybe I think NPTEL will give you the link already. Will give you the link for the folders and all, and I will upload this recorded lecture in YouTube. So if you have any doubt, you can go through again, and if you have any doubts in any lecture, then you can tell me. I will write it. I will go through that, and then I will understand it, and I will then uh, try to clear your doubts, because I myself do not go through all the lectures for making this one day tutorial, right? Okay. Okay. So I think that's it, and thank you for joining this class. Okay. And I want all of you to interact, not just say thank you at the last. Okay. 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 So I'm leaving this call for everybody.